Hello guys, good morning. Good morning to all of you. How are you all? So today in this lecture, we are going to discuss about special functions. So we have already covered the differential equations in I think 4 lectures we have uploaded. And today we are starting special functions. So today in this lecture, we are going to discuss. So special function, we will be considering 4 special functions. Just hold on a moment. Okay, so before I start, you guys tell me if you have any doubts in general, whatever we have discussed till now in the previous classes. If you have any doubt, any kind of doubt, you can ask me, then we can start this new session. No doubt? Okay, my coffee session is over almost. So let's start with special functions. So the first special function which we're going to discuss is the Legendre special function. Now before going directly into special function, we need to know about singular points and ordinary points of a differential equation. So yes Harani, tell me if any more doubts you have, you can let me know. Okay, this thing will be doing from the next session. Okay, like in the beginning of the session we can take your doubts. So once your doubts are cleared, then we can start the new session. This can be done. Singular points and ordinary points of a differential equation. As you can see, this is a general form of a differential equation, d square y by dx square plus p of x dy dx. So this p of x, as you can see, this is the coefficient of dy dx plus q of x equals to y. Now how we define ordinary points? So here two things you need to look at, p of x and q of x. If they remains finite at x equals to x naught, let's say your p of x is 1 by x minus 1. So if you choose x equals to 1, then it becomes infinite or undefined. But if you choose x equals to 0, then it remains finite. For x equals to 1, it becomes infinite. For x equals to 0, it remains finite. So x equals to 0 will be an ordinary point of the differential equation. What about a singular point? If either p of x or q of x or both, any or both, are infinite at x equals to x naught, then x equals to x naught is a singular point of the differential equation. Now let's say p of x is equals to 1 by x minus 1, q of x is equals to, let's say, 1 by x plus 1. So as you can see, let's say whole square, at x equals to 1, p of x is infinite, q of x is finite, then what will you call x equals to 1? X equal to will be called a singular point, because p of x is infinite. So any or both, or let's say p of x is equals to 1 by x minus 1, q of x, let us say 1 by x minus 1 whole square. And as you can see, at x equals to 1, at both, for x equals to 1, both p of x, q of x are infinite. Then also it will be called as singular point. Any of them, p of x, q of x are infinite, or both of them are infinite, then that point will be called singular point. Now there are two types of singular point. What are those two types? One is regular singular point, another one is irregular singular point. The first one is regular singular point. Regular or removable means these are singular point, but they can be removed. D or minus 1 minus x. Okay, we'll tell. Don't worry. Let's complete this topic, this singular ordinary, then we'll go further. Okay, regular singular point. So just write few lines. If p of x, q of x diverges means becomes infinity, 1 by 0. P of x, q of x diverges, but if you just multiply with x minus x naught is the singular point, but x minus x naught, p of x and x minus x naught whole square, q of x remain finite at x equals to x naught, then x equals to x naught is called regular or non-essential singular point. Understood this one? For an example, if you have, let's say, p of x is equals to, let's say, 1 by x, and q of x is equals to 1 by x square. So as you can see, x equals to 0, it is a singular point, because if you put x equals to 0, p of x is infinite or undefined, q of x also diverges. But when you consider x minus x0 px, means x minus x0 is this px 1 by x, it goes to 1. So this becomes finite. On the other hand, x minus 0 whole square 1 by x square equals to 1. This is also finite. So these are non-essential or regular singular point. You can remove the singularity. Understood? And the second type is the irregular singular point. If these were not the case, then they will get irregular singular point. So here, if p of x, q of x diverges, but either any one of them, x minus x naught px or x minus x naught whole square q of x, or both are infinite at x equals to x naught. So even after doing this x minus x naught whole square or x minus x naught, there remains infinite at x equals to x naught. Then we are writing it here, okay. Then x equals to x naught is called an irregular or essential singular point of the differential equation. Understood? Let me know once it is done. What is the meaning of diverging and infinite? Both are same. In this context, both are same. Diverging means the value is being very large. Okay. So for an example, very slight difference is there. When I am talking about, let's say 1 upon 0. So we can write the actual thing is undefined, but when we talk about mathematics, we generally call it infinite, or you can also call it at x equals to 0. If it is, let's say, 1 by x, then you can say at x equals to 0 it is diverging. So the slight difference between infinite and diverging is there. Infinite means it is 0, you are putting 0. Diverging, maybe you are putting infinitesimally small number. So in that case, you can use this term diverging. Let's say I am putting 1 by 0 point, let's say you are putting 0, 0, 0, 50 times 0. That is also approaching towards infinity. So in that case, you can say diverging. So both are like synonym with a slight difference. Infinite means purely you will put 0. Diverging means very close to 0. In that, you can understand in that way. For the present context, both the terms are same. Can you solve this problem? Find a singular point and the corresponding nature of singularity of the following differential equation. Hurry up, do it quickly. Where is Deep? Murli? Are you able to do this? Tell me the answer. So you can see the differential equation. We can write it in this way: y double prime. Let's divide by x into x minus 2 whole square on both sides. So 2 by x into x minus 2 y prime plus x plus 3 divided by x into x minus 2 whole square y equals to 0. From here what you can say that this is the coefficient of y prime. So this is your p of x, this is the coefficient of y, this is your q of x. C you are getting? Yes, C will be the answer. Now as you can see, if you put x equals to 0, so p of x and q of x are both infinite at points x equals to 0 as well as x equals to 2. So they both x equals to 2, therefore x equals to 0 and x equals to 2 both are singular point. This is the first thing we have concluded, they are singular points, but the nature of the singularity we need to understand. Now if you calculate x times px, okay, for let us say x equals to 0, so x minus 0 times px, what will be this value? 2 by x minus 2. This remains finite at x equals to 0. Okay, let's go here, and x minus 0 whole square qx, x plus 3. Okay, let's write qx directly. This is equals to x plus 3 divided by x minus 2 whole square. This is also finite at x equals to 0. So x equals to 0 is a regular singular point. Similarly, you can check for x equals to 2. So x minus 2 px, this will be 2 by x, this is finite at x equals to 2, x minus 2 whole square qx, this equals to x plus 3 by x, this is also finite at x equals to 2. So option C. Okay, let's quickly discuss about an integration technique. Harani has asked about it. So we'll be doing side by side two integrations. So one integration, if I remember correctly, integration of 1 by 1 by v dv, 1 by v ln v dvt. Okay, this one. So in usual technique, what you can write, let's say you can take ln v equals to some constant, let's say z. So this will be 1 by v dv equals to dz. So what you do for this case, you put 1 by v dv dz divided by ln v is z. So what you get? You get ln z, that is ln z is ln v. This is the usual way you do, right? Now the one which you used in our calculation, let's say dv by v ln v. Now you have identified that 1 by v dv is nothing but derivative of ln v, isn't it? You have taken derivative of ln v, that is why you have got 1 by v dv. So we can directly write 1 by v in place of 1 by v dv. We can directly write d of ln v. Okay, and ln v was there. So ln v was there. Now instead of taking this, you can consider ln v as a variable. So it is in the form of dz by z, dz by z. So we can what we are writing as a result, ln z if z was there. So what will you write here if ln v is there? So ln of ln v. So this is a technique which you can understand. And for the other thing, let's say what another example, let's take. Integration of what did we say, 1 minus minus 2x. So let's say 2x by 1 minus x square dx. This is the integration you need to do. So in the usual way, what you do, you let 1 minus x square is equals to, let's say, y, then what you do, minus 2x dx is equals to dy, then x dx is equals to minus half dy. Okay, you do this. So and in this way you get, let's say, minus dy by y. In this way you get, isn't it? But you can directly write, because 2x by 1 minus x square dx, you already know what is x dx. X dx is the derivative of 1 minus x square, and you have 1 minus x square at the denominator. So can you not write d of 1 minus x square? So d of 1 minus x square is minus x dx. 1 minus so minus half, you can divide into, here you can write 1 minus x square. So minus 2x dx, minus sign will be there. Now you imagine 1 minus x square as a variable. So dx by x type, so minus ln of 1 minus x square. Understood? So if you can do it fast, then you can use this technique, otherwise you will do this conventional technique. Understood, Harani? Look, this will take little time if you are learning it for the first time, this technique. If you have done it already, then it is not a big thing. So let's start with the special functions. So first of all, I am just giving you a brief overview of the differential equation. So 4 differential equations, 4 special functions you will be studying: Bessel, Legendre, Hermite and Logier. And as you can see, these are the differential equations you have. So just write them quickly. Then we will start with this first Legendre one. We can use log instead of yes, you can use log, but in physics we generally use ln. Yesterday you asked the same techniques. Okay. Look, even in the class, if you don't understand anything, some part, if you are not able to understand, you can message me on WhatsApp. Okay, I will explain to you. Did you write this part, this differential equation part? Just write done so that we can quickly move. Look, for each special function we need to know few things like the differential equation, the standard solution, okay, generating function, orthogonality relations, recurrence relations. Mainly these are the things you need to know for each special function. So I hope you have written all these 4 special functions. Let's go for the first one, Legendre differential equations. So you can give the heading Legendre differential equation, and the corresponding solution is known as the Legendre polynomial. Legendre differential equation. You understood the difference? The equation is called Legendre differential equation, and the solution of this Legendre differential equation is known as Legendre polynomial. This is the basic difference. So what is the general form? As you can see, it is 1 minus x square d square y by dx square minus, it's like taking derivative, 2x dy by dx plus n into n plus 1 y equals to 0. Let's say this is equation number 1. So you can also write this equation in this form, d dx of 1 minus x square times dy by dx plus n into n plus 1 y equals to 0. This n becomes the part of the integer. It may be 1, 2, 3 and so on. Here, can you tell me x equals to 0, what kind of point it is, ordinary or singular point? X equals to 0, is it an ordinary point or a singular point? Ordinary point, right? Now what about the general solution? Of the Legendre differential equation? Yes, ordinary. So two solutions are there. P and x is one of the solution. This is known as the Legendre polynomial. So since Pn of x and another solution is known as Qn of x, because second order differential equation it will have two independent solution, Pnx, Qnx are two linearly independent solution of the differential equation. The linear combination will also be a solution. General solution will be any linear combination of these two independent solutions, that will be the general solution. A and B are arbitrary constant. Now our main focus will be on this Pn of x, that is the Legendre polynomial. Means if you put Pn of x, this will satisfy this equation. Okay, in place of y, if you put Pn of x, that will satisfy this equation. Now Legendre polynomial of order n, Legendre polynomial, degree n, is given by Rodrigues formula. You need to remember this Rodrigues formula. What is this Rodrigues formula? Rodrigues formula is like a generator of this Legendre polynomial, or Legendre polynomial of degree n, Pn of x. This is written as 1 by 2 to the power n factorial, n derivative with respect to x of x square minus 1 whole to the power n. It means if you keep on putting the value of n, you will get different degrees of Legendre polynomial. You get P0 of x if you put n equals to 0, P1 of x if you put n equals to 1, P2 of x if you put n equals to 2. So first few Legendre polynomial you need to keep in mind. Firstly, let's say if n equals to 0, then what you get? If n equals to 0, P0 of x, this will be equals to, you can just put 1 by 2 to the power 0, 0 factorial, and this is 1, so this is equals to 1. Let's say if n equals to 1, what you get? P1 of x, this is equals to 1 upon, I am just showing you how to evaluate it, but you should remember the result, d dx of x square minus 1. So as you can see, this is half times 2x, this is equals to x. Put n equals to 2, P2 of x 1 by 2 to the power 2 factorial d square dx square x square minus 1 whole square. So this will be 1 upon 8 d dx of one time if derivative 2 into x square minus 1 and derivative of 2x, x square is 2x. I am just showing you how they are coming, but you can directly remember the final result. Okay, this is equals to 2 to 4 So 1 by 2 d dx of x is d dx of x into x square minus 1, and if you calculate this, what you get? You will get half x cube means 3x square minus xs 1. So these are the first three Legendre polynomial, and similarly you can evaluate higher order, higher degree Legendre polynomial. Let's say we can, if you put n equals to 3, you get p3 of x. p3 of x will be half times 5x cube minus 3x. You can calculate p4 of x, that will be 1 by 8 35 x to the power 4 minus 30 x square plus 3. Okay, so generally you can remember up to p3, half 5x cube minus 3, up to p3 you should remember. Now one thing have you noticed here, when you choose the even value of n, whether n equals to 0 or n equals to 2 or n equals to 4, this is you get n equals to 3, n equals to 4. So n equals to 0, n equals to 2 or n equals to 4, you see the function is even. This is also even, this is also even, this is also even. And on the other hand, when you choose n equals to 1 or n equals to 3 or n equals to 5, that function is odd function, odd, this is also odd, isn't it? Now we can just plot these functions. Let us try to plot these functions. The value of this Legendre polynomial will be varying between -1 to +1. Okay, so if I just plot it between Pn of x versus x, so roughly we can say that x is varying between -1 to +1. Let's say this is your +1. Now tell me, when you plot n equals to 0, p0x equals to 1, so what kind of graph you can expect? It is equals to 1, so we can say that it will be like this, it will be like this. Okay, this is your p0x, p1x is x, so what kind of graph you can expect? So we can expect a graph like this. This is p1x, p2x, it is a parabola, half 3x square minus 1. How? Here p0x is equals to 1, so for all values of x it is 1. p1x is x, so it is y equals to x graph. Okay. Now if you look at this closely, this is at x equals to 0, right? So at x equals to 0, what is its value? -half. So it should cut at -half. So this is the point where it will cut at the origin, and when you put p2x equals to 0, so 3x square minus 1 equals to 0, so x equals to plus minus 1 by root 3. Okay, so if I consider these points are plus minus root 3, so it will go like this. So it will be a parabola like this. Okay, so this point is 0.5 and these points are 1 by root 3 or plus 1 by root 3, this is minus 1 by root 3. 0 for odd, even. Yeah, n equals to 0 is considered to be even. So we can consider that even. N equals to 2 is also even, n equals to 4 is even. Even and odd, you know how to check even and odd. If you just replace x with minus x, if you get f of x, that is the condition to check even function. And if you get f of minus x by putting x equals to minus x, if you get minus of fx, then you can say that the function is odd function. So if you put x equals to minus x, so it becomes negative, so this becomes odd. But for this, x square is there, so if you put minus x, it doesn't change. You get back f of x, that is why they are even. Now you can also plot the third function. It will be something like this. Roughly it will go like this, cutting at origin. Now some observation you can have that the odd function is passing through the origin, whether p1x or p3x. So this one in red, it is p3x. So few notes you can write here. The number of roots means the values of x for which this Pn of x becoming 0, those are called roots. So the number of roots of a Legendre polynomial Pn of x why we take mod x less than equals to 1. That is the allowed value of Legendre polynomial. Okay, na? Legendre polynomial is taken between this plus minus 1. These are special functions, so they have a limited region of validity. The number of roots of a Legendre polynomial Pnx is always equal to its degree, which is n. So that is why for n equals to 0, it is not cutting at the origin. N equals to 1, it is cutting at 1 point. N equals to 2, it is cutting at 2 points. It is cutting the y axis at 2 points. You can see 1 point, 2 point. For n equals to 3, it is cutting at 3 points, 1, 2, 3. So cutting the x axis means the value of y is equals to 0. So number of roots is always equal to its degree. The roots are located in the interval plus minus 1. Minus 1 plus 1, and as you can see they are symmetrically distributed about the origin. If you consider this P3x, two roots are there, one is here, another one is here, they are symmetrically distributed about the origin. Okay. And are symmetrically distributed about the origin. Another thing to notice, number 2, for odd n there is always a root at x equals to 0. P1 x, one root at x equals to 0. P3x, one root will be definitely be there at x equals to 0. And the remaining n minus 1 roots are as usual symmetrically distributed within the interval minus 1 plus 1. Okay, very straightforward thing, you can easily see it from the graph. If you have any question, you can put forward. Now I think you have already know too much about the properties of Legendre polynomial. So let me just summarize the properties of Legendre polynomial. If you consider any Legendre polynomial and at x equals to 1, if you calculate, what value will you get at x equals to 1? Can anyone tell me? X equals to 1 means that at the end points, what value are you expecting? This is actually a box like structure, okay, like this. Of course, Murli. So Pn at x equals to 1 will be 1. Pn at x equals to minus 1. Look, at x equals to minus 1, it can be plus 1 or it can be minus 1. So it will depend upon minus 1 to the power n. You can write it in this way. And third thing, which we have already told you, that it is even for even value of n, it is odd for odd n. Pn of x is an even function of x for even n and is an odd function for odd n. Pn of x you know, but what will be the value of Pn at minus x? This you can calculate minus 1 to the power n Pn x, because it is symmetric about the origin. Number 5, Pn prime at x equals to 1. This has a special value. You can remember or you can also ignore it. N into n plus 1 by 2. Sometimes if you remember the properties, sometimes you get direct question using this property. So that helps you. So if you revise 3-4 times, then you can easily remember them. Pn at x equals to 0 equals to, look, this will be 0 if n is odd, because all the odd functions, as I have already told you, for odd n there is always a root at x equals to 0. So odd function will always give you a 0 value at the origin. So Pn at x equals to 0 is 0 if n is odd, but when n is even, as you have seen for the case of p2x, this was our p2x. For p2x you get a value of 0.5. For p4x you will get some other value, some finite value. Okay, so there is a formula to evaluate this: minus 1 to the power n 1 3 5 odd number and up to n minus 1 divided by even numbers 2 4 6. Very simple to remember. Let's say you have the natural numbers 1 2 3 4 5 6 7 8 9 10 and so on up to n, let's say. So minus 1 to the power n, odd numbers multiplication divided by even numbers multiplication. Simple. Notice one thing, that for the p0x the maximum power of x is 0. 1 is there, means we can consider that power of x is 0. p1x the maximum power of x is 1. p2x the maximum power of x is 2. p3x maximum power of x is 3. So whatever be the degree, that is the maximum power of x in the particular polynomial. Now we can represent any function using this Legendre polynomials. So let's try to do that. Previously question came based on this. You will be asked to represent a function in terms of the Legendre polynomial. I am giving you an example. Let's go for this problem. I hope this slide is done. So we have a problem like this. Express the polynomial given by this: f of x is equals to 4x cube minus 2x square minus 3x plus 8 in terms of Legendre polynomials. So as you can see, the maximum power of x here is 3. So we can use up to p3x, that will do our job. So if I simplify the meaning, you have to express this f of x in terms of the Legendre polynomial. So let's try to do this. So the first Legendre polynomial, we know p0x, then let me just write the values for you so that you understand it more clearly. p0x is 1, p1x is x, p2 of x half 3x square minus 1, p3x is 1/3, भूल गया मैं, half 3x square minus 1, p3x half 5x cube minus 3x. Fine. Now let this 4x cube minus 2x square minus 3x plus 8, we do not know how what will be the coefficient, but we can write it in a general term like a times p3x plus b times p2x plus c times p1x plus d times p0x. So if you are able to find out the value of a, b, c, d, then you can easily write. So let's put it, we'll put the values of this and we'll just compare on both sides, and finally we'll replace the values of a, b, c, d. So a, p3x is 5x cube by 2 minus 3x by 2, p2x 3x square by 2 minus half, p1x is x, p0x is 1. No issue. So this equals to 5 a x cube by 2 minus 3ax by 2 plus 3bx square by 2 minus b by 2 plus cx plus d. So let's try to gather the coefficient 5a x cube by 2. So we are gathering the coefficient of x cube, then we will gather the coefficient of x square, then x to the power 0. So x cube, now let's write the term related to x square, 3b x square by 2, then x, then x to the power 0. Okay, cx is there, so let's take common, minus 3a by 2 plus c times x minus b by 2 plus d. Clear? Now what you gonna do? Equating the coefficients of like powers of x, equal powers of x. We have 5a by 2 is equals to 4, 4 is equals to 5a by 2. From this you get a is equals to 8 by 5. So one value we have calculated, a is equals to 8 by 5. Now let's equate it with b, 3b by 2 is equals to minus 2, minus 2 is equals to 3b by 2, this gives b is equals to minus 4/3. See how simple it is. Let's equate minus 3 with minus 3a by 2 plus c. So the value of a we have already evaluated, 8 by 5, so minus 12 by 5 plus c, that gives c is equals to 12 by 5 minus 3 minus 3 by 5. Okay. And one thing is left, 8 equals to minus b by 2 plus d. B value we have already obtained, minus 4 by 3, so it is plus 2/3 plus d, that gives you d is equals to 8 minus 2/3, 22 by 3. And hence we can write f of x is equals to a times p3x, so 8 by 5 times p3x plus, so b times p2x, c times p1x, d times p0x. So with the help of this Legendre polynomial we could express f of x. So any function you can express using this Legendre polynomial. Do you understand this one? Tell me, guys. So let me give you a similar problem. Solve it quickly. The polynomial f of x equals to 1 plus 5x plus 3x square is written as a linear combination of the Legendre polynomials p0, p1, p2 as f of x equals to sum over cn pnx. So this is c0 p0x, c1 p1x, c2 p2x. So maximum power is 2 here, so it will go up to p2. So you have to find out the value of c0. Do it quickly and tell me the answer. This is simpler problem I have given you. I have solved the tougher one, left for you the simpler one. Follow the same procedure as I have given you. Equate, gather, evaluate. C. Yes, C will come. 1 plus 5x plus 3x square, C0 P0x C1 P1x C2 P2x. Okay, so C0 P0x is 1, C1 P1x C2 P2x. So let's gather this. C0 minus C2 by 2 plus C1 x plus 3 by 2 C2 x square. So what is the value of C2? So 3 by 2 C2 equals to 3, C2 is equals to 2, 1 equals to C0 minus C2 by 2, C0 equals to 1 plus 1. Understood, guys? Now let's talk about generating function of Legendre polynomial. Generating function means that will generate the Legendre polynomial. So you can give the heading generating function for Legendre polynomial. So the generating function is given by 1 minus 2xt plus t square to the power minus half is equals to sum over n is equals to 0 to infinity Pn of x t to the power n, this minus 1 less equals to x less equals to 1. Okay. So coefficient of t to the power n in the expansion of the generating function, you can see coefficient of t to the power n is Pnx, right? So coefficient of t to the power in the coefficient in the expansion of the Legendre polynomial, generating function of the Legendre polynomial what am I right? Is coefficient of t to the power n in the expansion of the generating function is the Legendre polynomial of order n. Okay. This relation sometimes is given already in the question, or it is better if you remember 1 minus 2xt plus t square to the power minus half equals to n equals to 0 to infinity Pnx t to the power n. Why it is called generating function? Because with the help of this expansion you are able to generate this Pn of x, that's why the name. Orthogonality of Legendre polynomial. The orthogonality relation also you need to remember. -1 to plus 1. P m of x, P n of x dx equals to 0 if m not equals to n. This is equals to 2 by 2n plus 1 if m equals to n. For an example, if you calculate minus 1 to plus 1, p2x p3x dx, that will give you 0. On the other hand, if you calculate, let's say p2x whole square dx, that will give you 2 by 2 into 2 plus 1, 2 by 5. Clear? Let's move on. Can you solve this problem? The generating function f of xt for the Legendre polynomial Pn of x is given by this, the value of p3 at n equals to x equals to minus 1. I think without solving it, but if you remember the properties well, you can do it. This came in December 2011. Can you tell me the answer? D. Look, by using the properties itself, we can directly tell it. If you look at this property, Pn of minus x equals to minus 1 to the power n Pnx. Okay. Let's do this. So we can use this generating function 1 minus 2xt plus t square to the power minus half. This is equals to n equals to 0 to infinity Pnx. Look, for this problem, they have already given you the generating function, but it may happen that you are not given the generating function. So you should remember. So what you do, you put x equals to minus 1 as expected, p3 at minus 1. So you have to put x equals to minus 1. Then what you get, 1 minus minus plus 2t plus t square to the power minus half. This is equals to n equals to 0 to infinity Pn of minus 1 t to the power n. So as you can see, n equals to 0 to infinity Pn of minus 1 t to the power n equals to, this is 1 by 1 plus t whole square and to the power half. So 1 by 1 plus t, that means 1 plus t inverse. This is equals to 1 minus t plus t square minus t cube plus t to the power 4 minus t to the power 5 and so on. Okay. Now as you can see clearly, if you consider p3 of minus 1, so you have to put n equals to 3, okay, now to get p3, of minus 1 tq. So here you can say this is equals to minus tq. If you just compare the coefficient of tq, that gives you p3 at minus 1 equals to minus 1. Option D. Okay, now there are some relations called recurrence relation. Few recurrence relations are there. It will be very good if you can remember. Even if you don't remember, that will not create much problem, but sometimes it may create problem. So you should remember these recurrence relations. So 6 recurrence relations, just write them one by one. And these recurrence relations can be proved. First recurrence relation, if you see n plus 1, pn plus 1x equals to 2n plus 1x pnx minus n pn minus 1x. n pn of x equals to x pn prime x minus pn minus 1 prime x. What is the meaning of pn minus 1 prime x? Means firstly you have to calculate pn minus 1x, then you have to take derivative. This prime means derivative. 2n plus 1 pn of x equals to pn plus 1 prime x minus pn minus 1 prime x. Pn prime x equals to x times pn minus 1 prime plus n times pn minus 1. Function of x you can write or not. X square minus 1 pn prime x equals to n x pn minus pn minus 1. X square minus 1 pn prime x equals to n plus 1 pn plus 1 x minus x pn x. Should we memorize all this? So ideally you should remember, but it is not possible. So even if you don't remember, that doesn't matter. Okay, don't remember. Okay, 1 or 2 you can remember. Those recurrence relations which are appearing repetitively, only those you can remember. So if you cannot remember all this, try to remember the first 2-3. Like this second relation is very important. 1 or 2 you can easily remember, that you can remember. Otherwise there is no requirement. Let me know once it is done, then we will try to prove these recurrence relations. One recurrence relation I will prove, and you can easily find out these recurrence relations even if you don't remember. If you can remember, then in your examination you can directly choose the option. Otherwise you have to calculate. So it is better if you calculate, because remembering this recurrence relation is for me is impossible. I cannot remember. But if some of you have good memory, then you can go for it. But I don't recommend you to overburden. Don't remember this. Now let me just show you the first proof. N plus 1 pn plus 1x equals to this. Is this slide done? Can you move forward to the next slide? Hurry up. And those who have already done, okay, let me know. Done. Okay. So the first formula 1, let's go for that. N plus 1 pn plus 1 x equals to 2n plus 1 x pnx minus n times Pn minus 1x. This we need to prove. So what you know from the generating function formula, 1 minus 2xt, so we can write 2xz also. T, z, these are variables, so you can choose any variable. 1 minus 2xz plus z square to the power minus half, this is equals to sum over, what was that, Pnx z to the power n. Okay, n equals to 0 to infinity, whatever we had. This is equation number 1. Now differentiating equation 1 with respect to z, we get, so if you take the differentiation with respect to z, what you get, minus half 1 minus 2xz plus z square minus half minus 1 minus 3 by 2, we have taken the derivative with respect to 2, so derivative of this thing, that gives you minus 2x plus 2z. This is equals to sum over n z to the power n minus 1 Pnx, which is treated as constant because we are carrying out the derivative with respect to z. Now what you do, multiplying both sides by, so minus 3 by 2 is there, we know about minus half, so that is why if you multiply with 1 minus 2xz plus z square, so that will become minus half again. That is why we are doing this, 1 minus 2xz plus z square. If you multiply, what you get, 1 minus 2xz plus z square to the power minus half you will get, and here you see minus 2, if you take common, x plus z, and this minus half is cancelled, so x minus z, if you take minus common, this is equals to, on the right hand side also we have to multiply 1 minus 2xz plus z square sum over n times z to the power n minus 1 Pn of x. So from this, what you can write, x minus z equals to x minus z. Okay, why should I write equals to 1 minus 2xz plus z square to the power minus half, this is equals to this, so we can put it, isn't it? 1 minus 2xz plus z square to the power minus half is this, so sum over Pnx z to the power n you can put, this is equals to the right hand side 1 minus 2xz plus z square sum over Pnx n z to the power n minus 1. Let's call it equation number 2. So now what you gonna do, equating the coefficients of z to the power n on both sides of equation 2. What do you get if you get the coefficient of z to the power n on both sides? So here what is the coefficient of z to the power n? Pnx. Okay, you have to multiply with z, right? Right, what you can get equating on both sides. Look, x into Pnx z to the power n, so x Pnx, this is the coefficient of z to the power n. Now you see z Pnx z to the power n, So what is the effective power of z? Z to the power n plus 1. So if you choose n equals to n minus 1, that will be Pn minus 1 z to the power n. So can we write it? Pn minus 1x, then z to the power n on the right hand side. You see, z to the power n minus 1 is there. What you can do so that n minus 1 becomes n? If you put n equals to n plus 1, then that becomes n, na? So 1 into Pnx n z to the power n minus 1. So you have to put n equals to n plus 1, and that will give you n plus 1. Here also Pn will become Pn plus 1x z to the power n. Now let's talk about this, minus 2x z times z to the power n minus 1. So that is z to the power n. So we don't need to do anything about it. So 2x n times Pnx you can write. Now z square and z to the power n minus 1. So it becomes z to the power n plus 1. So what you can do so that your n plus 1 becomes n? Obviously we put n minus 1, then it will become n. So what you can write here? Plus n is n minus 1 Pn minus 1 of x z to the power n. Now tell me if everybody has understood the last line. Last line everybody understood? Now gather the coefficients of Pnx, Pn minus 1x and all. So let's gather the coefficient of Pn plus 1x. Pn plus 1x is n plus 1. Pn plus 1x, this is equals to Pnx. So x is there, 2x is there, so it is 2n plus 1 times x times Pnx. What remains? Pn minus 1. So on that side if you take minus 1 plus minus n plus 1, so minus n. Okay, and I think that is what we need to prove. That is the proof. So in this way you can easily prove these recurrence relations. Let me give you one problem which came in December 2017. Can you do this problem? The generating function g of tx for the Legendre polynomial Pn of t is given by this. For mod x less than 1, means x is between plus minus 1. If the function f of x is defined by this integral equation 0 to x f of x prime dx prime equals to x g1x, it can be expressed as look this one, x times g1x means t equals to 1. So if you put t equals to 1, it becomes 1 by root over 1 minus 2x plus x square, that is 1 minus x whole square root. This is nothing but x by 1 minus x. Do it quickly. You have to represent fx in terms of the Legendre polynomial. Fx is defined by the integral equation. Look, as you have written here, zero to x f of x prime dx prime equals to x times g1x. So this is x times 1 upon 1 minus root 1 minus 2x plus x square x by 1 minus x. So x times 1 minus x inverse. So we can expand it 1 plus x square and so on. This is nothing but x plus x square plus x cube plus so on. Now if you take derivative of this integral equation, what you get? Take derivative on both sides. So this will become f of x, and if you take derivative on this side, 1 plus 2x plus 3x square plus 4x cube and so on. And what is this 1 plus 2x plus 3x square? This is the well known formula 1 minus x to the power minus 2, isn't it? So fx is what? 1 by 1 minus x whole square. Look at the options. You have to express it as the multiplication of Pn and Pm, isn't it? So you can just write it 1 upon 1 minus x, 1 upon 1 minus x. So somehow we need to express 1 by 1 minus x in the form of Pn and Pm. Now what is Pn? Pn at 1 is equals to 1 by 1 minus x, isn't it? You see, 1 upon root over 1 minus 2xt plus t square. This is what n equals to 0 to infinity x to the power n Pn of t. Okay. So if you write 1 upon root over 1 minus 2x plus 1 minus 2t plus 1, what you get? Sorry, वन माइनस हम लोग क्या लिखे हैं 1 minus 2xt plus x square. Okay, this one we made a mistake, x square. Now if you put t equals to 1, what you get? One minus 2x plus x square, 0 to infinity x to the power n Pn of 1, right? That is 1 by 1 minus x n equals to 0 to infinity x to the power n Pn of 1. Now Pn of 1 and Pm of 1 is same thing. One by 1 minus x, just the symbol change, m equals to 0 to infinity x to the power m Pm of 1. Can you write it or not? So we need to find out f of x. So f of x, which is equals to 1 upon 1 minus x times 1 upon 1 minus x. So can you not write n equals to 0 to infinity m equals to 0 to infinity x to the power n plus m, so multiplication Pn of 1 Pm of 1, that is matching with option B. Tell me guys if you have understood this problem or not. Simple problem, you just need to do little bit of adjustment. Now till now we have discussed about Pn of x, the Legendre polynomial. Legendre polynomial was one of the linearly independent solutions of the Legendre differential equation. Another linearly independent solution is there, that is denoted by Qn of x, that is Legendre function of second kind. The second solution of second type B, you should not write. Look, Legendre function of second kind of order n, it is denoted by Qn of x. Now you need to know about the first few values of this Qn of x. So n equals to 0, if you take, you get Q0 of x, it has a value half times ln 1 plus x by 1 minus x. As you can see, if you choose x equals to 1, then also it is undefined. If you choose x equals to minus 1, then also it is undefined. So at x equals to plus minus 1, this solution does not exist, you can see. q1 of x, this is equals to x by 2 ln 1 plus x by 1 minus x minus 1. q2 of x equals to 3x square minus 1 by 4 ln 1 plus x by 1 minus x minus 3 by 2 x. So there are some notes. Legendre function of second kind of order n is undefined at x equals to 0. And as you know, q1 of x is another solution. So the general solution we have already told you in the very beginning. General solution of Legendre differential equation will be written as y is equals to a times Pn of x b times Qn of x. Let me give you a problem. Look at this problem. The points where the series solution of the Legendre differential equation will diverge are located at. Where it is diverging? Quick. A, B, C, D. Look, this is a Legendre differential equation, so we can say that Qn of x will be its solution. Now, as I have already told you that Qn of x is not defined at x equals to plus minus 1. So, at that point x at ln 1 is undefined, right, diverging infinity. So, this is diverge, this diverge at x equals to plus minus 1, option C. Yes, Deep. Simple thing. Let's move on. Do this problem. given the recurrence relation for the Legendre polynomial. So most of the time recurrence relation will be already given in the question. Sometimes you may be required to use recurrence relation from your memory, but most of the time they will be providing you in the problem itself. So for this problem, you see the recurrence relation has been already provided. 2n plus 1 x pn x plus equals to n plus 1 pn plus 1 x n pn minus 1 x. The value of the integral minus 1 to 1, this h. Look, this problem is simple, although it is looking complicated, but it is simple. Here we have x square pn plus 1x pn minus 1x. So somehow if you calculate x times pn plus 1x and x times pn minus 1x, if you can find out some expression for these two using the recurrence relation, and you can multiply them, you can use orthogonality relations, okay na? Minus 1 to 1 pmx pnx equals to 0, m naught equals to n, 2 by 2n plus 1, m equals to 1, then you can easily do it. Will you give it a try? Let's do it together, okay? So first of all, this is a given recurrence relation, 2n plus 1 x pn of x n plus 1 pn plus 1x plus n pn minus 1x. Let's say this is equation number 1. What is our target? X square into this. So firstly we will calculate this, then multiply, then we will take the integration using this. What you gonna do? Put, you see you need n plus 1. So what you can do? Put n equals to n plus 1 in equation 1. So wherever you see n, just replace it with n plus 1. Any place wherever you see n, just replace it with n plus 1. So this is 2n plus 3 x pnx plus 1. This is n plus 2 pn plus 2 n plus 1 pn of x. So what you require? X times pnx. You can ask me, sir, pn plus 1 was there on the right hand side also, why you are not taking this? Because we don't need pn plus 1x, we need x times pn plus 1x, which is there. That is why we are operating n equals to n plus 1 or n equals to n minus 1 here. Although we had pn plus 1 pn minus 1 available, but x times pn plus 1 x there only on the term on the left hand side. That is why we have done this. So now you can easily find out x times pn plus 1x by dividing both sides by 2n plus 3. n plus 2 divided by 2n plus 3. What we have? Pn plus 2x plus n plus 1 2n plus 3 pnx. Is it clear till now? Let's name this equation equation number 2. ठीक है. Let us now put n is equals to n minus 1 in equation 1 to get x times Pn minus 1. So wherever you see n, replace it with n minus 1. Okay, so this is given us 2n minus 1 x Pn minus 1x n Pnx plus n minus 1 Pn minus 2x. Our goal is to achieve x Pn minus 1x. So this is n by 2n minus 1 Pn of x n minus 1 by 2n minus 1 Pn minus 2. Let's call it 3. And that is why when you calculate minus 1 to plus 1 x square Pn plus 1x Pn minus 1x dx, what you can write? Minus 1 to 1 x times Pn plus 1x x times Pn minus 1x dx. So we know the value of x times Pn plus 1x. Just put them, put it. It will be a big expression, minus 1 to 1. Firstly, let's put this one. So n plus 2 by 2n plus 3 Pn plus 2x plus n plus 1 by 2n plus 3 Pn of x and this value n by 2n minus 1 Pnx plus n minus 1 by 2n minus 1 Pn minus 2 dx. Now which values you will take? Look at this orthogonality relation again. Whenever m not equals to n, it will be 0 and it will be non-zero only when m equals to n. So if you multiply these two terms, how many terms you will get? 4 terms. Look, this one will be multiplied with 1, 2 terms, this one 1, 2, 4 terms will get. But which one will survive? For which those Pn plus 2 or Pn or Pn minus 2, where these values are same, m equals to n. So which one will survive? Only one will survive, Pn and Pn. Only this one will survive, Pn square. So what we have, n into n plus 1 divided by 2n minus 1 times 2n plus 3 minus 1 to plus 1 Pn of x whole square dx. Can we write it? Now Pn of x whole square dx is 2 by 2n plus 1. So 2 times n into n plus 1 divided by 2n minus 1. This is 2 by 2n plus 1, and this 2n plus 3 was there. How simple it is. It is matching with option A. Only the calculation is looking broad or large, but the problem in itself is very easy. Option A. Tell me guys if you have understood or not. Isn't it simple? Is there any difficulty in this problem? So we are almost at the end of this class. I am just giving you one problem as homework. You will try at home. Similar problem, simple. And you can share the solution in on the WhatsApp group. Chalo. Is this problem done? Do it and tell me when you are done. Ajay, Harani, Deep, Karthik, is it done? Quick guys, hurry up. Look at this problem. One problem I am giving you at home to do at home. You will do this problem at home. The value of the integral minus 1 to plus 1, 1 minus x square pn prime of x whole square dx will be. Okay, so with this we conclude the session here. Thank you very much for joining the session, and all of you like the video, okay, so that it can reach to a wider audience. And see you guys tomorrow at 8 AM. Bye bye, take care.